Alrighty, here we're integrating the square root of x squared minus 1 over x dx. The square root the square root of a quadratic is telling you to think about using the Pythagorean trig identities as a way to substitute an x theta in for x. And so what you want to do first is get this into a form that looks like x squared minus 1. So first, I recommend dividing by cosine squared, because if you do that, then you'll see that tangent squared equals 1, tangent squared plus 1 equals secant squared, so then tangent squared equals secant squared minus 1. Now, this little guy looks a whole heck of a lot like this x squared minus 1, and so this expression here looks a heck of a lot like x squared minus 1 if you see x as equal to secant theta. We'll make this substitution. That makes dx equal to secant theta tangent theta, and rewrite the integral in terms of theta. So now we have the square root of secant squared theta minus 1 over secant theta. That's coming from this x here. This dx is now written as secant theta tangent theta d theta, and then the secants cancel. Well, this secant squared minus theta is here. Well, this equals tangent theta, so this is really a tangent times this tangent, and this is tangent squared d theta. So now we've written this integral as the integral of tangent squared theta. You have two options here that I could see. One, you want to use integration by parts on sine theta over sine theta over cosine squared theta d theta. That's one option. I think an easier option would be to rewrite tangent theta using this identity again as secant squared theta minus 1 d theta, and then the integral of secant theta is just tangent theta, and then the integral of negative 1 is just negative theta, and then we add on our c. And you want to go back then and write theta as a function of x. Since x is equal to secant theta, well, theta is inverse secant of x. So your final answer is tangent inverse secant of x minus inverse secant of x plus c. That's it.